So just a real quick recap here. Make sure you guys got some of the key things from that handout. What would happen with this here? Yeah, so the answer is 3, because 7 to a power and log base 7 kill each other. The answer is 3. Another way to look at it is, that is the number that when you raise 7 to it, you get 3. So when you raise 7 to it, you get freaking 3. All right? I love that explanation, but that's another example of how weird I am. Much better, and I agree, much better, these damn things kill each other. There. Rah. So the same exact way, what would log base pi of pi to the 12th power be? 12. I like it. Okay, cool. So that's some very basic little stuff there, right? But just to show you how else this could be used. If I said, what's log base 3 of 243? You can break this down. 3 times 81. 9 times 9, 3 times 3 times 3 times 3. So how can I rewrite this? This is log base 3 of 3 to the what power? 1, 2, 3, 4, 5, right? All right, let me stop there for a second. So I took the number 243, freaky ass number. I broke it down, which is a good idea when I have a freaky ass number I'm supposed to do something with. See what it's made of. So it's made of how many 3s? 5 of them. So based on what we just did, what happens? So the answer is 5. Which makes sense, because again, this is asking how many 3s does it take to multiply to be this? And this is writing, this is saying it takes 5 3s to multiply to be this. That's why these get out of the frickin' way, because the answer is staring you in the face. When you write it as a power, the answer is right there. Alright, maybe. Alright, okay. Just another way to kind of go further and think about it. Okay. Let me make sure I didn't skip anything in this section. Blah, 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 blah. Blah, 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 blah. Okay, cool. I like it. Yeah, cool. I like it. Cool. So, the last thing we're doing today. We're going to get out of here a little early, just to let you know. So remind me, what are the properties of powers? When I have like-based things.
Multiplication is actually addition. Is that what you mean?
Yeah, so when I have like bases, when I multiply those like bases, I add powers. Now.
And when you square powers, you multiply them.
I like it. Cool.
When you power powers, you multiply.
Power. When you power the power, you multiply. I like it. Exactly. So remember, logs are powers. So when I have the log, let me do this. All right, let's stop here and analyze what this says. Bless you. This is the product of two things, and they both have a base of x. So these are two different things. Like if this was A and this was B, they both have base x. I like it. So when I multiply these two things that have base x, what would I do with their powers? Add them. So what's the power for A? It's log xa. Because what does a log represent? Power. Kick ass. So that's the power related to the A. That's like the 3. That's like the 3. I would add it to the power that's on the B. That's like the 4. So that is the property of logarithms. The log of a product is the sum of the logs. What's a better way to say that? When I multiply things with like bases, I add the powers. Do you see what I mean by all the log properties have to be the exact same thing as the power properties, because logs are powers. Exactly. Okay, maybe. I don't know why more math teachers don't say it like that. Because that's what it is. I make it sound so horrible. Now notice, so here I am multiplying two things with like bases. What can I do if I add two things with like bases? Can I do shit with this? I gave it away the way I said it, but dear God, don't tell me it's even worse. If you say that's the answer, I don't see any x to the 7s. How do you get 2 of them? That's like a math Jesus thing. Right? And then there were enough x to the 7s for everybody. I'm sorry. A little sacrilegious. Too bad, Jeff. So what I'm saying is, if I saw this, I cannot do shit with this. What do I do with it when I add like bases? Nothing. Depends on what the powers are, and I don't know what they are. So nothing. So this I can't do anything with. But what do I do when I multiply like bases? I can add the power. So the log of a product is the sum of the logs. The way we use this actually is kind of in reverse. So for example, if I said log base 10 of 2 plus log base 10 of 5. Anybody know what log base 10 of 2 is? No. Good. Well, if you did, that would be a little freaky. A little Rain Man-ish, right? Definitely, I don't know what. No, is that too far long ago? Rain Man, Tom Cruise, back when he wasn't so crazy. But what's the property say I can do? When do I add powers? These must have been doing what? Multiplying. So this is log base 10 of 2 times 5. All right, let me stop there for a second. That's that property in reverse, right? Because math goes both ways. Don't judge. Yes?
2 multiply 5 is 10. It's not 1 of the answer 1.
Yes, the answer is going to be 1. Exactly. So next step, log base 10 of 10. What do I raise 10 to make 10? 1. I'm going to let you think about that. Soak it in. The biggest mistake people make is they do something with this. You can't do shit with this. This is just like this question. Like bases, but do you know what the powers are? No. What can I do? Nothing. There's nothing I can do. Yes, sir.
What about coefficients?
All right, we're getting there. So this is the first property. Yes?
So at the top one, you'd add the 2 and the 5. The bottoms are 10.
So what would this look like here? Is that what you're saying?
Uh-huh.
Okay. I like the way you're thinking. So Jeff, you used this example to build this. Now please do the same thing for me here. Okay. Let me see if I can magic that up. So the base would be 10, right? So stay with me then. Do I know what... So my point here, I don't know what the power is here. But so stay with me. This is a good question. This is what I always kind of try to show, and I love that you asked it. So it's not me. I'm answering your question. I'm sorry, Sierra. I didn't mean to say, it's her. This is a little weird, but this is cool. So what do I raise 10 to make 2? I don't know. So let's say, so what do I say if I don't know? Let's call it x. So 10 to the x is 2, let's say. Is that cool?
Yeah.
10 to the I don't know is 2. And 10 to the something else is 5. Cool? So here I'm adding those powers, right? So I don't want to say this. So it must mean that when would I add these powers? When would I add the powers? These aren't the powers. I must have been doing what? So let me see if I can. It's a little bit sideways from the way I normally do it, but this. So what is this? This would be x plus y. Right. Stay with me now. Because wouldn't log base 10 of 2 be x? Let me make sure everybody understands. Let me go there. Log base 10 of 2 is what? I don't know, x. So 10 to the x is 2. All right. So log base 10 of 2 is x. Log base 10 of 5 is y. Because again, I don't know what it is, so let me call it y. Now, when would I add these?
When you're multiplying.
I must have been multiplying these. All right, I like it. Where am I going with this? Yeah, okay. So, okay, sure, Jeff. So this will work. It's sideways from where, but this will work beautifully. So if I multiply these, then wouldn't that be 2 times 5? Is that cool?
No.
Why? What?
Because 10 and then it's same base, you put the 10.
No. All right, let me make sure you understand. What is 10 to the x?
It's 10. It's 2.
2. What is 10 to the y?
5.
5. Okay, is that cool? Are you guys kind of with me?
Yeah.
And some of you guys have already kind of like, whatever, man. Okay. Beautiful question. Difficult to kind of represent so that everybody understands, but still it's worthwhile. It is. I really want this to make sense. What I don't know when you write this is what the power is. But the power is this. This is the power. I just don't know what the hell it is. So I call it x to kind of write it. So 10 to some power is 2. That's true. There is a power that makes 10 become 2. There is. I don't know what the hell it is. So 10 to the power is 2. 10 to the power is 5. When would I be adding them when I multiply? So this would be 10 to the x plus y equals 10 to the first. Right? So what the logarithms say is only look at the powers. When would I be adding the powers? When I'm multiplying the stuff, right? So I would be adding the powers when I'm multiplying the stuff. And if you look at the powers, what do the powers add to be? They add to be 1. So that does work. So the logarithms focus on what the powers are doing. So if the bases are the same, when would I be adding these powers? When I'm multiplying the things. That's why this property works. So let me give you a more concrete example. That's freaky example. Let's do something we can all see. What's log base 2 of 4? 2. What's log base 2 of 8? 3. So log base 2 of 4 times 8 should be log base 2 of 4 plus log base 2 of 8. Let me stop there. So what I just did here was I just blindly applied the property. Log base 2 of 4 times 8 must be log base 2 of 4 plus log base 2 of 8. That's what the property says, right? When you multiply stuff, you must add the powers. Well, we can check this. This is not a proof, but it's at least a feeling out of what the freaking hell is going on. So what is 4 times 8? And what's log base 2 of 32? 5. And of course, what's log base 2 of 4? 2. What's log base 2 of 8? 3. Alright, so that works. So if you look at the powers individually, or you look at the powers after you multiply the stuff, of course they're going to be the same as long as you're adding them, right? When you multiply like bases, you have to add the powers. So what do you think is going to be related to division? What other property am I going to have now? Yeah, when do I subtract powers? What must I have been doing? I must have been dividing. Become a B. Okay, maybe. So again, I really want this to make sense. The power on the result of A divided by B must be the difference in the powers on both. All right, so let's take a look at the concrete example. Let's say A is 3 cubed, and let's say B is... actually, let's make it more general. Let's say A is x to the 5th, and B is x to the 3rd. So what this is saying is, okay, divide them and then look at the power on them, right? That's what the log does. It focuses on the power. So if I divide A by B, what do I get? X squared. So the power on that is equal to the power on this minus the power on that, right? That's all it's saying. That's all it's saying. A logarithm looks at the power. So the power on the result of this will of course be the power of the top dude minus the power of the bottom dude. Well, if you look at it like that, it's like, well, duh, that's the idea. So logarithms just look at only the power. So when I divide two things with like bases, I subtract the powers on them. Ooh, right? I really want this to make sense.
There are no numbers here. It's all powers. Like, they're numbers, but you know.
Yeah, they're all powers. I like the way you said it. They're not really numbers,
Yeah.
right? There is no 5 here. There's XXXXX. And I just wrote it in a compact form. But there is no number 5 here. I like it. If that helps you, great. It's true, but I don't, okay. All right. How are we doing so far? Again, the mistake people make is they'll look at this, A minus B, and they'll do something. There isn't shit you can do with this. What do you do when you subtract like bases? What's B to the 7th minus B to the 2nd?
B to the 7th minus B to the 2nd.
You can't do shit with it. Thank you. There's no property for this. There's all day long a property for this. We know what the property is when I divide like bases. I have no idea what to do if I subtract like bases. It depends on what the power. I don't know what the powers are. I don't know what the power. So screw it. I can't do shit. Maybe. Okay. All right. Final property. The final property. Let me build it from this, and then I'll show you how it's the same as a power property. Go with me now. If log base x of a b equals log x a plus log x b, what do you think log base x of a base c d is?
Log of x a plus
Log x a plus log x b. Oh, yes. Thank God it only went 4. Okay. All right. That's the way to make fun of how boring it is as you're doing it. So that I agree is kind of boring. But it leads to this shortcut. What if I had log base x of x times x times x times x? Get out of there, x's. Let me make it a times a times a times a times a times a, blah, blah, blah. Let's just do that many. That'd be log base x of a, log base x of a. But isn't there a shortcut?
log x a to the 5th.
No, be careful. Be careful. It'd be log base x of a. You're going to make you write it out, aren't you? Plus, let me make them be fewer a's there. Log base a x of a plus log base x of a plus log base x of a, right? Which is what? Come on, you can do it. How many log base x's of a are there?
4.
4. So it would be 4 log base x of a. All right, now watch. There's a shortcut in here. Dear God, never do this shit. There's a shortcut. What's a better way to write a times a times a times a? Log base x of a to the. Look what happened to the power. It just. Because like Nathan said earlier, this is the hardest one to see as rule-wise. But if I had x to the b raised to the 4th power, what do you do with the powers? Multiply them. So look at this. Log base x of a to the 4th power. I take the power times the power. So it's still the same property. When you raise something with a power to a power, you multiply the powers. But this rule has a quicker way to say it. When you have a log of something with a power on it, the power comes down. It's a shortcut. There's a shortcut way to say it. Let me show you another example. So once you get the gist of that, it's pretty straightforward. So if I saw log base w of, doesn't matter, Jeff, m to the 1/4, that equals what? 1/4 log base w of m. Let's do a concrete example. Always nice to do a concrete freaking example, Jeff. So what's log base 2 of 16 to the 1/4? Well, let's be dumb about this. Not dumb, but because we know what 16 to the 1/4 power is, right? But pretend like we don't know. We only know this property. So what would happen to this?
1/4 log base 2 is 16.
And what's log base 2 of 16?
4.
Good, because 2 to the 4th is 16. And what's 1/4 of 4? 1. Why was all this kind of stupid? It's just an example of the property, because what is 16 to the 1/4 power? 2. And what's log base 2 of 2? Freaking 1, thank you, right? So if the property is true, it better keep the answer the same, or else screw that property. And thankfully, it kept the answer the same. This is not a proof, it's just a feeling out of why it makes sense. That cuts this power down by 1/4. This cuts this power down by 1/4. They both do the same damn thing, so of course the answer comes out the same. Maybe. So on one level, the computation required here is not very extensive. The other level of conceptually understanding why it works, that's a little more intensive. But it's all based on properties of powers. They're exactly the same. All right, so with that said, if you flip over, all right, first off, take that handout back out, flip it over, and there's some red writing there. Red writing. So try those problems out. You can get back in your groups together if you want to or not. If you're tired to talk to those other people. You with me? What's going on, everybody? Some of you guys have already done it, so just help people near you if they need it. Or stare at your favorite wall. If you haven't picked a favorite wall yet, what the hell? That's the first thing I do when I come in to a room. Ceiling sometimes is my favorite walls.
Okay, so